Right, bandsaw versus big chunk of rubber. This is actually a lot harder than you would think. Rubber, by its very nature, is resistant to abrasion, wear, damage. That's one of the reasons your car tires are made of rubber, is it puts up with abrasion. And bandsaws are basically big, giant abrasion machines. A little more sophisticated than that, obviously. The bandsaw, in this case, we're using a 1 inch wide, 3 tooth per inch, hook tooth style blade. Typical, what you might use to cut wood or metal. And I've had mixed results in the past with trying to cut rubber. This is a fairly hard rubber. This big chunk is used in railroad crossings, so the cars can run over the tracks. But we've had mixed results cutting rubber. We're going to try and cut this one. The bandsaw we're using today is model 2054. Has the traveling table with a variable variable speed powered traveling table drive. Blade motor is a 5 horsepower brake motor running at a fixed speed about 3,000 feet per minute. We're running pneumatic tensioning on this at about 17,000 psi on the blade. I've got a basic controls on this, so all the controls are located on the control panel back over there where you can't see it, but I'll control the machine from there. I'll get the fence. This machine has our optional precision workpiece positioning fence. Very nice. Moves like a lathe cross slide. Very smooth, precise, just generally nice. So what I'll do is I'll start the blade motor up, start the table, I'll ease the workpiece up to the blade, and then I'm going to start very slow. I don't know how well this is going to cut and how fast I'll be able to cut, so I'm going to ease into it very gently. I'm going to run dust collection, but if this starts burning, or smoldering, it could produce a lot of smoke. But this is as much an experiment as anything, and I'm curious to find out the results. Rick, could you turn the dust collection system on for me, please?
Yes, sir.
Thank you. Start the blade motor. I currently have the table advanced speed set at 0 right now. Actually, I'm going to lower that upper guard a little bit. This machine, the upper guard is mounted on a post with adjustable height. I'm a little closer to the material than that. You want to minimize the free distance here between the bottom of the upper blade guide and the workpiece. It does two things for you. It keeps you a shorter working blade length, so it's more stable, and it guards the unused part of the blade. Okay, get up to it, and I'm going to back the speed down to just about 0, and then very delicately ease into the workpiece. The table drive motor is controlled with a variable frequency drive, so I have really good control over the blade speed. But I do have a minimum on the blade speed I can get away with here. I do expect this material to cut slowly. I'd be happy to be proven wrong. Maybe I can cut through it quickly, but I'm going to start on the conservative assumption. My guiding philosophy here is that I need to get a good quality cut before I get a fast cut. If I don't get a good quality cut, I'm not going to sell anything to anybody. If I do get a good quality cut, then we can work on speed. Well, starting off just fine. Let me get the blade all the way into the workpiece and I'll try increasing the speed, see if I can get away with that. So far, we're not working the saw that hard. I am starting to smell some rubber though. Okay, the blade is all the way in the workpiece. taking it just fine. Give it a little more beans. I can hear the blades singing a bit. Rick, would you stand here and watch the saw stop button and the table stop button? I want to put eyes on this from a couple different angles. We're tracking great and we're not working the saw that hard. Okay, I can increase the speed a little bit more. Excuse me. Starting to work the saw a little bit. I probably have a little more speed I can give it. This is one of the reasons I like building saws that have the remote control pin, and I can walk around the saw, watch the cut, and still control the saw. Right now, to do anything, I have to be at the control panel. Like I said, these are our basic controls. If you want the handheld pendant you may have seen me use in other videos, that comes in either our enhanced or variable speed control package. But once you know what speed works for you, you can usually just set up a cut and walk away, let it run. I'm going to get a little greedy here and give it just a touch more speed. I'm running at about 10% of table full speed. Full speed is 2 inches per second, so I'm running at 0.2 inches per second approximately. Not real fast. But we're cutting. I'm fairly certain there is more speed to be had in this cut. I'm not working the saw all that hard. We're tracking very well. But I'll save it for a future exercise to find out just how fast we can cut once I've proven that we can get a good quality cut. Rick, after the cut goes through, I'm going to want you and me go around back, grab the workpiece, bring it up here so I can show the camera the cut surface. I think it'll still take two of us to carry even that cut off piece. Okay. Although you're pretty damn strong, you might be able to handle it on your own. Don't think I could. Okay, we're about 3 inches from breakthrough here. Breaking through, we are seeing sparks. Boom. Go ahead and stop everything. Excellent. Can you hoist that thing? Yeah, set it over here on the edge of this, oriented so the viewing audience at home can see the cut. Oh, that's dandy. That worked really well.
Oh, yeah.
Zoom in on that for you. I am pleased. Oh, that is beautiful. That is beautiful. That is a straight, beautiful cut. It's not, it's clean in the sense that the workpiece is very smooth. It's a very smooth, straight cut, no burring, no fuzzing. It's glorious. The produced dust, however, is nasty and sticky. But that is a complete and total success. Thank you for watching. If you have any questions, please feel free to call or email us here at Forest Manufacturing. Thank you.